first step is to mark the tree. For this, a wooden scale, a tape, and a marking knife is used. Using the scale, a height of 120 centimeters is marked. The girth is measured and divided into two. Based on this measurement, the tree is divided and marked as two sections. An aluminium stencil which is made at a 30-degree angle to the horizontal is used for marking, as this ensures a maximum amount of latex can be collected. The lower end of the stencil is kept at the mark of 120 centimeters. A vertical line called nettikanu is drawn here, and another line called poikanu is drawn at the upper end of the stencil. Tapping occurs from the high left to the low right, and the method followed is a continuous excision tapping method. Stencils come in different dimensions depending on how often the tree is tapped. Next, the total volume of latex, which is around 4,000 liters that has been collected, is transferred into the bulking tank. Dilution is done by adding water in order to standardize the DRC. Field latex has a DRC of around 30%, and it comes to around 21% after dilution. Dilution is important because it allows uniform distribution of chemicals that are to be added, and it reduces viscosity, thereby leading to easy processing. Then, sodium metabisulfite is added in order to stop enzymatic discoloration in the latex. Sodium bisulfite is put next in order to separate rubber fractions and prevent enzymatic discoloration. 50 to 75 grams of sodium bisulfite is added to 100 kilograms of the dry rubber content. Mixing with a pedal is done to separate rubber from rubber fractions which are present up to 10 to 15%, and the latex is transferred to the coagulation tank, which is situated below the bulking tank, allowing gravity to act. Milling is carried out to obtain uniform rubber sheets. The coagulated rubber is cut into smaller chunks for easy handling, and then wet milling begins. The first mill is a diamond mill, and it reduces the thickness of the sheets. The second mill is a spiral mill. Here, a uniform sheet with less holes are produced. In wet milling, water is used to reduce friction and to wash off any acid from the rubber. Dry milling is next used to extrude the water added to the rubber sheets, and around 7 mills are used. The rubber sheets are then placed on a standard wooden wheel that is rotated thrice to obtain uniform sized rubber sheets for drying. The rubber sheets can be dried using two methods, natural drying or artificial drying. Natural drying takes place by allowing ambient air circulation produced naturally to remove moisture from the rubber sheets hung. In artificial drying, water is heated and heat is supplied using radiators to the rubber in a closed setting. This is completed within 3 to 4 days. The dried rubber sheets are then passed through laminating rollers. The natural behavior of rubber and the high pressure applied by the machines allows a variety of ranges from 3 to 12 layers to be laminated together based on the customer's requirement. The final step in the manufacturing process is packaging. The rubber sheets are packed in polythene covers. The weight is measured up to 25 kilograms and is compressed for easy packing. Crepe rubber manufacturing is a complex procedure, yet satisfying, as the initially harvested latex can be converted to different products like medical gloves, infant pacifiers, seals, carpets, and tiles. More information regarding rubber plantations can be obtained from the Rubber Research Institute of Sri Lanka, located in Agalawatta, and any details with regard to rubber manufacturing will be provided by the institute in Ratmalana. We hope this video gave you a good understanding on rubber. Thank you all for watching.